This is a great example here of what we call differential erosion. You can see that the multicolored clay-rich rock or mud-rich rock is easy to erode. In fact, you can see how it's been excavated away from this cliff face over here in the distance, so much so that it's allowed for the much more resistant sandstone at the top to form an overhang and then for the overhang to fall. And you can see all those fallen overhangs there. You can also see an overhang at the top of this little pinnacle here. The only reason that this pyramid-shaped clump of mud is there is because a long time ago, a landslide of those sandstone blocks came over here, and that block has essentially armored the rest of the pyramid-shaped glob of mud from being eroded as fast. So it is eroding some, but because of that, it's shielded. You can see here that the mud is really, really easy. It's hard to even call this a rock. The reason it's so easy to erode, to dissolve, and to break apart is because it's made up of volcanic ash. And as you look back, you can see that there's layer after layer after layer of volcanic ash here. This formation, which is called the petrified forest member of the Chinle Formation, documents when subduction started on the western edge of North America in the Triassic. And that's a very, very important time because the whole edge of western North America changed. It used to be what we call a passive margin, where the continent was eroding, the rivers were moving from the center of the continent to the edge of the continent, and sediment was piling up on the edge, a long ways away from a plate boundary. But once subduction started on the edge of western North America, those sediments that were piled there started to be contorted and folded. And the subducting slab that went under the edge of western North America caused water to go into the mantle and flux melt the mantle. And so we had these volcanoes arise all along the western edge. If you go to California or Oregon or Washington, you can see the Sierra Nevada mountain range or the Cascade mountain range, which is essentially that same system. And the ashes from those volcanoes were blowing eastward due to the prevailing winds. And this is where they're stacking up. So this was the beginning of the end of an era of western North America, a passive era that lasted almost 400 million years. And these ashes were like a shot over the bow of that passive margin, saying eventually this whole area here is going to be changed in that it's going to go from an ocean bed to a mountain belt. And you can see that all of these layers here were deposited by very, very low energy systems, and all of that changed. Now the rivers are coming from the west into the continent because that's where the mountains are. The whole edge of western North America and South America has been crumpled.